Good afternoon, everyone. Hope you guys are enjoying the session so far. In this session, we're going to talk about Spark applications, how to build Spark applications with Yugabyte. Before diving in, let me introduce myself. My name is Ayyappa Chintham. I'm a Principal Solutions Architect at Yugabyte. In my role, I work with customers to educate them with best practices and enables them to use YB effectively. Before joining Yugabyte, I worked with companies like Pivotal and HP. Today's agenda is we're going to cover overview of Yugabyte architecture. I know in the last couple of days, we have covered Yugabyte architecture a few times. I'll just go through quickly if anybody missed them. We are also going to cover Yugabyte YSQL API and additional features that are coming with YSQL API in Yugabyte. And we will cover what is Yugabyte DB Spark connector and how we can use it to connect between Spark and Yugabyte. At last, we will show you a quick demo on how to use and build Spark applications with Yugabyte database. Yugabyte DB is a highly scalable transaction system. It is distributed SQL database, meaning data is spread across the nodes in the cluster. It is designed for a very high resiliency. On top of that, YB is 100% open source, where everybody can get access to the code and be able to contribute to the code. YB has a Postgres compatible API, which allows customers to quickly adapt to YB without a lot of learning curve. It can be implemented in any of the customer cloud environments, either in public cloud or in private cloud. Yugabyte DB is designed for cloud-native microservices. It is developed with inspiration from Google Spanner, which first introduced distributed systems with consistency. But unlike Google Spanner, which created its own SQL syntax, we have created YSQL and YSQL APIs, which are compatible with Postgres and Cassandra query languages, respectively. We have created DocDB, which is a distributed document store common across both the APIs. DocDB is designed with auto-sharding, and it uses graph consensus protocol for replication and fault tolerance. DocDB uses highly customized RocksDB as a storage engine. Today, we are going to use YSQL with Yugabyte Spark connector to connect to Spark and build applications in Spark. YSQL is a query layer, which is compatible with Cassandra workloads. In addition to Cassandra SQL API, we have created a strongly consistent secondary indexes, and also we support JSON natively. On top of that, we have used distributed ACID transactions to enable distributed SQL. Okay, here in this case, actually, we are going to show you an example of secondary indexes. When we create a table, we create a primary key, which by default creates an index. On top of those columns, we can create secondary indexes in Yugabyte, which are consistent. So in this example, we have created a table with ID as a partition key and a category as a clustering key. Both together forms a primary key. On top of that, the primary key, we have created another secondary index on the columns, category, sales, rank, and ID. So in this scenario, if there is a query coming in with the product ID, it uses the primary key index to fetch the data from the database. In the second case, we can use a second category column, which we have created as a secondary index to list top products in the category. As we discussed earlier, when we say distributed transactions, we are talking about the ability to run queries autonomically on multiple shards. And in Yugabyte, we can easily enable distributed transactions by enabling the transactions on the table. So in this example, we are running a transaction which are using two different tables. So in this example, what we are doing is on the product inventory, we are taking out the quantities, and when the order is there, we are adding that quantity to the order. So this transaction is atomical in the sense like if one of them fails, the whole transactions will be failed. We do not want that the product inventory is, the quantity is reduced in the product inventory, but in the orders, the quantity is not added. Those kind of scenarios are where we are providing the consistency across multiple transactions. So in Yugabyte, in addition to what Cassandra query language client provides, we have added support for JSON. That means that we can use JSON data as a column in the tables and query on those JSON columns and JSON elements individually. On top of the native JSON, we also support observed operation on the JSON column. So in this example, we can see that for the ID 6, initially in the JSON field, we had only editors. Now, After that, by using the update statement, we have added authors element into the JSON. So we have added only authors. And if you can see at the end, the authors element is added to already existing editors element, making it the whole JSON column. So the YugabyteDB Spark connector is the one which we use to connect to the Yugabyte from the Spark application. So like we discussed earlier, we support JSON-B natively, meaning that we can do column pruning, like how you do in the Postgres and some other databases on the JSON columns. So this is very useful in the cases where you have a lot of JSON elements and you are only looking for few elements in a select statement. So instead of bringing whole JSON object, we are actually working on few columns and provide those columns to the select output. So in the Spark connector, we also support performance optimization with predicate pushdown, meaning when the where conditions on that Spark applications, in cases where it is efficient to push down to the databases, that will be pushed to the database, and database will execute that query with where conditions and provide that output to the Spark application. We also support cluster and topology and partition awareness for the Yugabyte. So meaning when a Spark application runs, it creates the partitions and does that create the task based on the Yugabyte cluster information. With that, let's quickly go through the demo. As I explained to you earlier, for this demo purpose, we are using a Yugabyte Cloud database. So we connect to the Yugabyte Cloud by using cloud.yugabyte.com. Once you go to that website, first-time users, it will allow you to create an account, and it will ask for the verification through email. Once the email has been verified, then user will be able to create a free Yugabyte cluster. So in my case, I have already created an account and database. So after I log in, I can see my universe in the website. For the new users, once you log into the cloud, it will ask you to create a new database, and the user can provide the information about the availability zone and the cluster name. Once the information has been provided, it will take about 5-10 minutes to create the cluster. In this case, it will actually create the node and then whatever the software required, and then create the database in that. So in my case, I have already created the database, so I can see the cluster information. So once a cluster is created, in the connect information, it will provide us how we can connect to this cluster from application. So in this case, since we are concerned about YSQL, in YSQL, it will provide the local data center and host name and port. It will also provide the CA certificate, which we will be using to connect to the database. Now that the cluster is created, we can connect to the cluster through our YSQL client and verify the cluster. So as you can see, actually, I'm using the host name, which is created by the cloud database. And from that, from the CA certificate I have downloaded, I'm using that CA certificate to connect to the database. So after connecting the cluster, we can see, so when the new cluster is created, when the database is created, by default, Yugabyte creates all the system tables for storing and managing that Yugabyte resources. Okay, and so far we do not have any user-defined tables. Okay, so let's quickly create some of the tables we are going to use, and while we are doing that, I will just explain to you what we are creating and how we are going to use them. Okay, so in this example, so first we are just creating a table and inserting some rows into that. So in this case, we are creating table EMP and then grading 10-15 records into that one. First, we are going to create a key space and the table for our demo. Okay, and I'm storing some data. And now we can see that the table has been loaded. Okay, we will also create another table and we have added extra column rank in that to show you that how we can write data from Spark to Yugabyte. So in this case, I'm creating EMP write with the additional column rank. Okay. Okay, so for a JSON example, I will also create one more table. So in this case, books, and I'm inserting some 5 records into that to show you. Okay, let's quickly check that. Store.books. Okay. Now, so in this demo purpose, we are actually going to use Spark Shell to run our Spark application. So you can use the same thing and create a Scala application itself and then run it. But in this, for demo quick purpose, we are going to use a Spark Shell. Okay. So, so as you can see here, we have given the packages. Okay, the packages to specify that the Spark connector from YB. Okay. So this is a small local cluster, Spark cluster, and I'm using that Spark to connect to the database which we created in Yugabyte Cloud. Okay, now So first, in the Spark application, as usual, we'll import all the dependencies required for our functions. Now, we are defining some variables in the Spark shell, which we will use for the connection later. So in this case, we have whatever we have got the information from cloud, we are using that one, the host, key space, and whatever that rest of the things. Okay. Next, we will create the Spark conf. So here you can see that for initially, I'm just using temporary host. So which I will override in my Spark session. Okay, so now we have a Spark session which we can use to create data frames and run queries in the database. So first thing we will try is we will create the data frame and see what the data we have inserted in the EMP. So here we can YB see whatever we have inserted earlier in that the EMP table. Now we can access that information from Spark application. So like that, we can run other Spark functions, count, and df underscore YB print schema. So now, as you can see, once we have established the connection, we can do all the Spark functions on the YB. Now, so to quickly show you how we can write into the Yugabyte. So first what we will do is on this demo example, okay, we will we will create another column rank. So we will rank based on the salary, based on the job, okay, partition by job and order by salary, okay. So for that, we can use Spark transformations. So in this case, I'm just creating a window function, window spec. Okay, so by using that window spec, I'm going to actually write the data into into EMP write table. So before writing, actually, we can check what is the current data available in the EMP write. So for that, apart from the function we have seen earlier, we can also use Spark SQL. Okay, in this case, we'll use for var emp underscore right. Spark SQL. Select star from if we show df underscore emp show, so you can see that there is no data now. So now, so we have created a window function, and with that window function, we are actually loading the data into the emp write. So now if I try to do it again, now you can see that we have a new column in emp write with rank data. So you can also see that for data is ordered by salary. When I say ordered by, the rank is created based on the salary. Okay, now, okay, so as we explained to you earlier, the Spark connector, Yugabyte Spark connector supports JSON objects natively. So for this purpose, we can use that another table we created, store underscore books. So we can quickly see how we can use it to access data. So here, actually, you can see that So this is our data. We have two columns. One is ID and the other one is detail. As you can see here, details is actually a JSON-B column. So we also have entered data into that. Now, we can use that window functions. Sorry, we can use that JSON functions to access that one. So here we have created, if we see the show. So here you can see that we have actually used a JSON element filter to access the data. Okay, this is about the JSON. Before I would also quickly want to give you about, show you about how we can use the upsert operation. Okay, so in this table, store books, we have 5 records now. So let's quickly add one more. Okay, we are adding one more record into that. And when we select that, okay, for ID number 6, we can see that we have just created a new document, and we just used only element name with test JSON upsert. Okay, so when we do the upsert operation, if the JSON element is completely new, then that element will be inserted. If that element is old one, then that element is updated. So if I add a new one, in this case, so I'm just adding a new element author into that ID6. If we select now, so now you can see that previously we had name and a new author element is added to the JSON object. That is the quick demo I want to show you guys. Thanks a lot for attending the session. Appreciate your time. Hope you guys are going to enjoy the rest of the sessions. Thank you. Bye.